Okay.
Anton, you may presentation show for us. Oh, yes.
Can you see it?
Yes, yes.
Okay. One second.
Sustainable agriculture planning.
So can you hear me? Can you see my screen?
Yes.
Okay, super. Good afternoon, colleagues. I want to present my article, which is called Sustainable Agricultural Planning via Temperature Trend Analysis, a Candlestick and Fractal Approach. About me, in 2 words, my name is Anton Chernytevich. I'm a PhD student of Department of Mathematical Modeling and Data Analysis at Kyiv Polytechnical Institute. My current occupation is software engineer manager at Oblivion Finance. I have like 10 years of applied experience in commercial R&D, and I have 2 cats. That's worth to mention because they never give me a possibility to present peacefully, so you may see them. Back to content. I will focus on 4 parts about my article. First one is motivation and inspiration. It's crucial at this moment. My objective, results, and conclusions and discussions that I will propose. So first of all, inspiration was caused by my analysis of financial markets, where I was trying to research the fractal markets, fractal patterns, which are presented on fractal in financial markets. So if we want to decompose one candle of higher time frame, we will receive the structure of candles that will have the same size, may have the same size, and same patterns of the higher candle, but on lower time frame. That was quite interesting for me, and later I was also inspired by trend lines, which more often are used that visual instruments, but they typically drawn by a strict rule, by not a strict rule, rather by extremum points, which are highlighted on chart representation on candlestick data. But these similar patterns occur on candlestick charts, and they occur on different time frames. So when we will decompose the higher time frame into lower time frames, we may see the similar patterns of fractals and may see the similar nature. So that inspiration was boosted my motivation to apply this approach not only on financial and markets, but rather to explore this approach on other data patterns, data nature, like temperature data. So as we can see, the temperature data visualization somehow, some kind remind us about the financial markets. They are different, these data patterns and these charts, but still some patterns may be quite similar, even if the temperature data visualized is much more smoother. Also, I wanted to deeper and investigate this approach if it even can be applied in temperature data or climatic data. So I found the work and research about trend lines and candlestick representation applications on wind data. So the guys, Giuselini and Izaguirre, showed that it can work, it may be used, and it may show the promising results. So their conclusion was about implementation in machine learning approaches for forecasting to boost the results, to boost the forecasting metrics and so forth. But I tried to use analytical approach first of all, in first hand. So the third part of my motivation was the sustainability problem. So Ukraine loses the crops not only due to direct damage on the fields during the full-scale war, but also during the follow-up issues like transportation, trading, and field processing. This is the global problem because issues in Ukraine also cause the global problems with crops. Yep. So my objective was kind of risky, but also promising because my goal was to develop and validate the novel methodology where we can apply candlestick charts, fractal analysis on temperature, combined with temperature analysis, and try to predict a trend, but not as a common approach for trend prediction, but rather the more strict, more promising and optimized trend detection. And apply this in sustainable agriculture in current geopolitical context. So the farmers could have a toolkit to measure the minimum, maximum values of the upcoming temperature, like row or channel. For example, the minimal temperature is -2 and the maximum +8 and so forth. Proposed methodology consists of 4 major steps. The first one is data preprocessing, and likely this is one of the most crucial parts here, because if we process temperature data and try to aggregate it into a candlestick, it's very important to find a proper starting point. For example, during my experiments, I found that starting point at 5 a.m. daily and have 8-hour fractal, 8-hour candle aggregation with fractal size of 6 candles is pretty okay for trend detection and further analysis. The second part is fractal detection, upcoming, like we have the algorithm that stores the previous information about our structure, about our trend lines, and so forth. And we just wait for a new candle upcoming candle. For example, if we decided to select the 8-hour fractal, 8-hour aggregation period for candle, so then we will have a delay, for example, of that 8 hours to properly detect the fractal. And later on, when we analyzed our newly processed candle, we can process fractal, we can process trend analysis, and to try to detect is there any reversal patterns in this trend. So for my data, I took the samples from Copernicus, just hourly temperature data for 2021-2024, but my main focus was on fully available data, latest fully available data, which is 2023. So as you can see here, if we just aggregate by the starting point at 12 a.m. and aggregate candles into one-day candlesticks, the data is quite noisy and not very informative. for both in visual analysis and algorithmic analysis, because one day candlesticks white often starts matches the open temperature of the day and close temperature of the day. So if you can see on the smaller chunk, it's still quite noisy, especially in September, not in September, on summer and on winter. So as Fractal, I chose the common approach in financial markets. These fractals are just made of a batch of n candles. So for example, if you want to highlight the fractal of 5 candles, you just need to be sure that the middle candle is the highest or the lowest in current situation. Also, I extended this approach by not only selecting the odd number of n, but also we can select the even number of n's, where we shift the fractal pattern forward. So for example, if we want to select the fractal of 6 candles, we select the 2 candles on the left and 3 candles on the right from the middle point. So if we apply this algorithm, when we form fractals, we wait for new candles, we wait to analyze these fractal patterns, we can clearly see that it selects also the extremum points, which are crucial for our specific topic when we want to see when we want to reach the information, get the information about the minimum and maximum values for upcoming period. In some points, it still works not pretty well. For example, in the middle point, as you can see here, but I already have some ideas how to enhance this performance of this algorithm. So as for validation results, I selected for this presentation the chunk, the latest available chunk in 2023 from November till the end of the year. And if we apply this methodology, we can see that the trend line, that our trend changed 3 times. So these purple lines represent the places where our trend changes. It has quite a good precision in overall, but still there are a lot of like noisy moments. For example, this lower fractal, because it's likely not the change of the trend, but rather the extra point. Yep. So in conclusion, first of all, I validated the idea that generally this approach may work, and it particularly shows the promising results. On second hand, it's pretty lightweight because we can pretty simply scale it. If we want to deploy if you want to deploy or use our algorithm in some systems, and it's not resource hungry. So for example, we can use it even deploy it even on our mobile phones and have it right with our hands. So it showed promising results because of low delays. So typically we analyze the reversal trends by just one more candle that will approach to form fractal, and we will analyze this fractal. And for not like perfect parts of this methodology is it's hungry to fine tuning of these fractals. So, for example, we need to strictly select which size of fractal do we need, what starting point should we use, and so forth. For example, my proposed approach showed the promising results, but other approaches should be investigated also. And during the pretty high-level investigation of this problem, because it's only the starting point of diving deeper. It's just it can be used just like a supportive toolkit for existing systems. So it's not a standalone measurement tool yet, but it may be used in blend with some well-known systems and may boost the performance. And so what's next? 3 steps are already done. So validation step was okay. Algorithm development is also done, and results interpretation too. So the following step is quite important step, as we should find the metrics and compare the proper metrics and find the and then compare these metrics to the state-of-the-art models to measure the performance of this approach as a standalone approach. And after receiving the results, if they will be competitive with other models, then we can apply this approach to other data, other data structures, other data sources. For example, those data which were presented by Erizoro, wind data, and so forth. Thanks. Feel free to reach me out with any questions. Also, the demo of this methodology and algorithm will be available on my GitHub. It will be free to use with all the comments, and that's it. Thank you. If you have any questions.